So, hello everyone. Today we are going to solve the next question. So, the question name is total cuts. You are given an array A of n integers and an integer k, and your task is to find the total number of cuts that you can make such that for each cut these two conditions are satisfied. Okay. So, we have to divide an array into two parts. So, we'll get one subarray and another subarray, and the subarray should have at least one element. Okay, and it should be equal or unequal length. So we have to check the sum of largest element in the left part and smallest element in the right part. So we and sum should be greater than or equal to k. So here, if you take an example, 1, 2, 3, 4, 5. So if we can divide this array into two sub arrays, in how many ways we can divide it in four ways. So 1 and 2, 3, 4, 5. Again, next 1, 2, and 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, and 5. So in this way we can divide. So what we have to check, sum of largest element in the left part. So here largest element L equal to 1, and right side smallest element is 2. So the sum is 3, and it should be greater than or equal to k. Let's say we'll take k sum. Right now we'll not take any condition. We are just finding the sum, and we have to check if the sum is greater than or equal to k. Then we have to increment that, we can make a cut. Similarly, here largest will be 2 and smallest will be 3. And in next case, largest will be 3, smallest will be 4. Largest will be 4 and smallest will be 5. So, using naive approach, how we can solve? So, we are given an array A. So, what we have to do? Here, I'll write a function to click. Okay, we have to use static min. So, here you have to pass index start, comma int. Sorry, yeah, int. So here I'm passing an array and start and end. So it will return a minimum element between this start and end, the array with index start and end. Okay. So for int I equal to start is less than or equal to end I plus plus. So let's say int main equal to, we'll take AR of start, and main equal to math dot main of main comma AR of I. And return. Similarly, we can find the maximum element. So here also it pass the same thing, start and end, and flags. We have to find the maximum, right? So here in the left part we have to find the maximum, in the right part we have to find the smallest. So we'll call this function for our left part, and this function for our right part. Okay. Now for int I equal to 0, I is less than min, I plus plus, we have to check if the sum. So if maximum of, I mean the largest of left part. So max of. So how we are doing the cuts, we have already seen. We have to divide it in two parts only. So at each index we can do the cut. So if I is equal to 0, then maximum of, so we are passing the array. Start index will be 0 and end index will also be 0. And for minimum, for the right part, here, so instead of like, here we have to pass the I, 0 to I, and here I plus 1 to, so instead of n we have to pass n minus 1. Okay, so see here, if it should be greater than or equal to k. So in this condition we have to find the left part of max. So if we cut here, so 0 to I and I to n minus 1. So these two sub array we will get. So we have to find the largest element in the left sub array and smallest element in the right sub array, and we have to add those two numbers, and if we have to check if it is greater than or equal to k. If it is greater than or equal to k, then we have to, let's say I'll take a count. We have to increment the count. Okay, and then we have to return the count. Let's check. Okay, so here, yeah, so it's n minus 1. we are getting array out of bound index at position minimum of start. Okay, so start is 0. Let me check what I'm getting. Index 3 out of 3 index 64 86 50. Hmm. Yeah. So here we have to take n minus 1 as we are passing I plus 1. If we take n minus 1, I mean if I is less than n, n minus 1 will also get. So n minus 1 plus 1 will be n. So that's why we were getting the array of the bound index. So we have to do only if number of elements are 5, then we are doing 4 cuts only, right? So n minus 1 times only we have to use the loop for n minus 1 times. Okay, so we are getting the output. If we check for, okay, this is already, if we check for this one, okay, we are getting the output. So this is what we are doing. We every time we are checking the least element, I mean largest element in the left side and smallest element in the right side. Okay, so how we can optimize this solution? So the efficient approach is to use the prefix. So before, how we used to find the prefix sum, similarly we can find the smallest element. So what was prefix sum? Sum till that index. Okay, so sum at index I is equal to 2 will be sum at index I minus 1. Okay, so here what we can do, let's say the same example. What if, okay, if we take the same example, so what was k? K was 6. Yes. Okay, so if we take this example, from left side, I'm finding the least element. Till I is equal to 0, the least. Okay, so from left, we have to find the largest element. So till I is equal to 0, what is the largest element? 2. And now what is the largest element? 6. Now 10. 10. 10. So at index I is equal to 2, the largest element from left is 10. From at index I is equal to 3, largest element from left is 10. So this is what, this is the largest element from left. And now if we see the smallest element from the right, we have to go from the back. Okay, so this is here 8, then 2. We have to find the smallest. So from end, so we how we calculated from start, similarly we have to calculate from the end. So from end, now 8 is only there, so 8 is the smallest element. Now next 2 is the smallest element, again 2, 2 and 2. So in this way we'll get this array. One is largest from the left and one is smallest from the right. So after this element, which is the smallest element, 2, after this element, after this element, after this, and here only 8 is there. So we got these two arrays. One is largest element from left and smallest element from the right. Okay, so now what we can do here, here what we did is we have to find the largest element from left and smallest element from right. So at every cut we have to find. So here, okay, this is different example. So if we see this one, how many cuts we can do? N minus 1. So 2, 6, 10, 2, 8. This is the one cut. 2, 6, 10, 2, 8. 2, 6, 10, and 2, 8 space 2. 2, 6, 10, 2, 8. Okay. This many we can do the cuts. Okay. And yeah, so here if we see, in this case the largest element is 2 and the smallest element is also 2. Here in this case the largest element is 6 and the smallest element is 2. Here in this case the largest element is 10 and smallest element is 2. And here in this case the largest element is 10 and the smallest element is 8. Okay, so here how we can find this? So here 2 and 1. Okay. Sorry for the disturbance. Okay, so where we were? Okay, so here if we check the largest from left and smallest from right. So here at the last point, I mean this, at this point, so what we have to check is in this way. So largest here and the smallest here. This is the first element. Okay, so see, this is the first element. For first element, for first left this L, this is an array, let's say. This is the largest element and largest element from left and smallest element from right. So largest, we have to do a cut, uh, and the two we'll get two subarrays, right? So largest element here and smallest here. So we have to check the ith. Let's say this is the ith, then I plus one, like smallest of I plus one and largest of I. So here, if you see, the first element here, if you see the first element we are including here, but for the smallest, we have to check the next all elements, right? So here we have to check this one, and for largest, for left we have to check this one. Okay, so if we write the code, we have to first print the two arrays. Likewise, so we did prefix and suffix, right? Now we have to do the largest and smallest. So if we pick this array, smallest equal to min int n, or int n equal to 0. So wait, so L of 0, sorry, L of 0 will be A of 0, and S of n minus 1 will be A of n minus 1. Okay, and now for int I equal to 1 as less than n, I plus plus, L of I equal to math dot what largest max of, it will be L of I minus 1, comma, current element. We'll use the same rule, but what will be I will be n minus 2, n minus 2, and I should be greater than or equal to 0. I minus minus S of what, I plus 1, no, I S of I equal to math dot max. What is math dot max? So S of I will be the minimum, sorry, not max, it's minimum, we are finding minimum, right? So minimum of the this and the current element. What is this? This is S of I plus 1. So 5 plus 1 and current element. So now we got this two array. Now what we have to check, let's say count for int I equal to 0, I is less than. See here we have to check n minus 1, because we know we can do only n minus 1 cuts. So if L of I plus S of I plus 1 is greater than or equal to k, then we have to increment the count. So here, see, why we are taking I and I plus 1 is, so if we check in the example, the first element we are not including in the second array, right? I mean, we are doing a cut where we got one subarray and another subarray, and here, if we ideally check the first element of array here, if you check one is not part of second subarray, any, like, if here two possibilities are there, but the first element here, the first element is 1, it is a not part of second subarray, right? So that's why we are not counting S of I, and also the last element is will be never be a part of a first or left array. That's why we are not taking L of I plus 1. Okay, so if here the condition would be like, here it is given non-zero. If it was if the condition was like this, condition was not given, then we can directly check L of I and S of I also. Okay, so if we count and then we have to return. So if we run this, oh sorry, return count, sorry. Yeah, we got the output now. Yes, we are getting the output. So in this way we can make use of prefix concept, okay, to solve this question. And yes, thank you.